Hello friends, in this video I will explain about set operations. Okay, different concepts related to set operation I will explain in this video. So let's start. So the first topic under this set operation is Venn diagram. So what is Venn diagram? So this is a diagram to represent set and set operations. Okay, so it is a type of diagram which is used to represent set or set operation. For example, here you can see A. So this is a diagram which is used to represent a set. Okay, so in subsequent sections I will show you how Venn diagrams can be used to represent set and set operations. Okay, now here it is given subset. What is subset? So subset is if every element of B is also an element of A. So every element of B is also an element of A, then B is the subset. So this is the notation which we use for subset. So B is a subset of A. For example, A is the set of digits 1 to 5 and B is 4 and 5. So since 4 and 5, which is B, is present, means 4 and 5 are present in set A, so that's why B is a subset of what? A. Now next here it comes the proper subset. So what is proper subset? So if every element of B belongs to A, but every element of A is not an element of B. Okay, so same thing here. If every element of B here present in A, but every element of A is not present in B, because in B 1, 2, 3 are not present in B. So it means B, we can say, is also a proper subset. Okay, this is the condition for being a proper subset. For being a proper subset, A means each element of B must be the element of A, but another condition is also there, that each element of A should not be in B. Okay, so then in that case it is going to be called a proper subset. There is a difference between subset and so proper subset comes under, means proper subset is a type of subset. Okay, because it is a type of subset, because subset include proper subset. Okay, because here in this example, this is an example of what? Subset. B is a subset of A, and here in the second, B is also a proper subset. So it means a proper subset is a type of subset. Okay, then after, here it is given union of sets. So union of set here, if A and B given, so A union B meaning A union B has all elements of A and B. So, and one thing which you have to keep in your mind, that we don't have to repeat elements. Okay, so here 1 2 3 4 here, and 5 6 7, so all the elements we have to write here. So now in in symbolic form we can write down like this: x, vertical column, vertical line you can write down, or column you can write. Okay, x is an element, x belongs to A. It means x is representing the element of this A union B set. So x belongs to A or x belongs to B. It means x is also the element of A and x is also the element of B. Okay, here again you have to keep in your mind that you don't have to repeat the elements. Okay, all elements should be written only once. So A union A union A is always A, because same A set A union set A, it will give A union omega. So this is I'm using to represent universal set. Okay, this one I'm using for universal set. So whenever any set is in union with the universal set, then the result it will be universal set. Okay, because universal set contains all the elements of set A. Okay, then after A union null set, A union phi means phi is used to represent null set. So null set means there is no element, so always the union will be A. Okay, because nothing more is going to be included in the union, because null set contains nothing. So since nothing means, so A union null set meaning A you will get only. Then A union B will be equals to B union A. This is commutative law. It means union of sets follow commutative law. So you can change the order. So you can write down A union B, or A union B you can write down, or B union B, same thing. Then the next thing here, which is it is another so now you can see here. So this is associative law. It means A union, and if first we do the function of bracket, so B union C first we have to do. So you can change the order. Okay, here you are doing union of B and C first, then after you are doing with A. So you can change the order. First in the right hand side you are doing first A and B, union of A and B, then you are doing with C. Okay, this is associative law. You can change the order. Then after B, you know what is the proper subset. Now you can see here, then if B is, you know what, a proper subset, it means all elements of B are present in A. So in that case A union B will be A. Okay, example here it is shown. So A, so 1 2 3 4 5 is set A, and set B is 1 and 2. So now in this case you can see here, so here A union B equals this. So why? So A union B is all elements of A and B we have to include. When we include, so we will get this. Okay, so and one, this is nothing but only A. So that's why A union B here in this case is only A. And then after the intersection of set, intersection contains all the elements which are present in both the sets A and B. Okay, if elements are present in both set A and B, then in that case that is known as intersection. So here in the symbolic notation we can write here in curly bracket x vertical line, or you can write in column x belongs to A, and this symbol is used for and. So x belongs to A and x belongs to B. It means x belongs to both A and B. Okay. So for example I can write down here just like A, if it is 1 comma 2 comma 3, and B equals to only 2. Okay, then A intersection B. So you have to find out what is common. So here in this case A, only 2 is the common in A, is common in both, so we can write down 2. So this is it. Okay, then after disjoint, do not have any common element. Okay, so if for example here it is 5, means if two sets are given A and B, and if there is no element common, then that those sets are known as disjoint set. For example, if A equals to 1 comma 2, okay, and B equals 3 comma 4, so there is nothing common in these two, so that's why here A intersection B will be 5. Okay, then complement of set. So complement of set, here you can see, so x and x belongs to universal set. So x is the element and x belongs to universal set, and x does not belong to A. It means complement of A means all elements which are present in universal set and which are not in set A. For example, universal set omega, here it is shown like this, and A is given this. So complement of A means you have to write all the elements except whatever elements are present in A. So in A, 1 to 3 present. So except means we have to exclude 1 2 3, and remaining elements we have to write. So remaining elements are 4 5 6 7. So this is the A complement. Okay, next here it is the De Morgan's rule. Okay, so in De Morgan's rule, here it says that a complement of a union of A and B will be equal to intersection of A complement and B complement. And here you have the difference of sets. So if A and B are two sets, and if you are finding the difference, then that will be equals. So this is by using symbol. So x belongs to A union and x does not belong to B. So all the elements which does not belong to B, we have to find that with A, means we have to find the intersection of A with elements which are not present in B. So that we can write down like this. So which are not present in B meaning that is B complement. So A intersection B complement. Okay, so here given by example, this is the omega, means that is universal set. This is A, this is B, and B complement means we have to exclude the element of B from the universal set, and those, so 1 2 1 3 7 are present in B. So exclude 1 3 7 from the universal set, so you will get B complement. So you have here B complement, and then you can find out simple intersection of A in A minus B equals A intersection B complement. So B complement A, you already have this 2 4 6, and intersection so whatever B complement you got, so that you have to write and then find out. So the parts which are common here, you have to write down those elements. So those elements are 2 4 and 6 only. Okay, now so one more thing. So reflexive property, set a set is a subset of itself, means all set is a subset of itself because all elements are present in a antisymmetric property. Means in this case antisymmetric means if A is a subset of B and B is a subset of A, means in both are, means A is subset of B, it means all elements of A are present in B, and in this case B is subset of A means all elements of B are present in A, then A will be equal to B. Then transitive means if A is subset of B and B is subset of C, then A will be also a subset of C. Okay, so here B is common in both, so first will be the subset of the last, C. And the last topic, which is the power set. So what is power set? The set of all subset of a set. Okay, the set of all, so now you can see here, set of all subset of a set is called the power set. For example, here given if A equals here 1 comma 2, so the all subsets of A will be 5 1 and 2. So these are subsets 1 comma 2, because subsets you already know the elements should be present in A. So 1 is present in A, 2 is also present in A, 1 comma 2 is also present in A, and you know that 5, this is null set, so this is always present in all set, so this is also present in A. So power set means we can write down all, means these all we have to write down as element in this case. Okay, so here here these are sets, but here these are acting as elements. Okay, so how many elements are there? 4 5 1 2 and 1 comma 2, so these are 4 elements. So thank you all for watching. So to watch more such videos on mathematics and statistics, you can like, subscribe, share, and write in the comment section for more videos related to the topic. Okay, or you can suggest any improvement is required, then I will definitely make improvement. So thank you.